So in the last video, we discussed the notion of parametrics. Now, in this video, we're going to practice graphing a fairly simple parametric equation, parametric equations. So let's say we have our x variable defined such that t of t squared minus 2t, and let's say our y variable is defined with t plus 1. So x is equal to t squared minus 2t, and y is equal to t plus 1. So each value of t in this case gives us a point on the curve, and the point on our curve will be, our dimensions will be x and y. So let's go ahead and make a chart with t values, in this case, x values and y values. So again, now what we're doing is we don't only have x and y values, because now x and y are both dependent variables and t is our independent variable. So we need t added here. So t, x, y. So if we plug in 0 for t, actually here, let's start with some negative values. Let's start with -3, and we'll go probably up to 3 or so. So if we start with -3, let's see, for x we get -3 squared minus 2 times -3. That's 9 plus 6, so we got 15. -3 for y, we end up getting -3 plus 1, which is -2. All right, let's do -2. If we plug in -2, we get -2 squared, which is 4, and then minus -2 times, or minus 2 times -2, so it's plus 4, so that's 8. For our y value, we end up getting -1, and then, so let's go a little bit quicker here. -1, we plug in -1, we get 3. We get 0 for y. If we plug in 0, we get 0, and then 1 for y. And then we want some symmetry, so there's a high probability that this curve has some sort of symmetry with this, so we're going to go up to all the way to 3. So that helps us figure out what the symmetry is and how the curve looks like. So if we plug in 1, we get -1, and 2. Plug in 2, we get 0 and 3. Plug in 3, we get 3 and 4. Alright, I think we're ready to graph. So again, we're going to draw our x and y axis. Keep in mind there is no t axis. T is just t is the independent variable, and we don't show t. You can think of t as just time. So alright, first point we have is 15, -2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. -2, so right here. Next point we have is 8, -1. So 1, 2, 3, 4, 5, 6, 7, 8, -1 right here. So far, we have 2 points. We cannot assume this is linear, so we're gonna have to keep plotting points. Next one we have is 3, 0. So 3, 0 is right here. Next thing we have is 0, 1. So right here. -1, 2, right here. 0, 3. So notice how at 0 there's actually we have 1 for y, and then we have 3 for y. So this is definitely not a function, right? This is for a certain x value, there's not one unique y value. In this case there's 2. So that right there shows us that this is not a function. But that's alright, because we can still graph it as a parametric equations. And our last point that we plotted is 3, 4. So 1, 2, 3, and then 4, somewhere around there. So it looks like it's going to keep going like such. So let's see if we can draw this out. So let's connect these ones. Something like this would be our curve. Obviously this is not accurate. You can see how this curve looks with infinite accuracy on a computer, but this is a great representation of how this parametric equation would look like.